This is for year 11 methods. We're going to look at the exercise 9F, which is talking about conditional probability. Okay, so the idea behind conditional probability is that we're given a prior piece of information, and this prior piece of information changes the probability that we calculate. Okay, let's do a simple example. For example, if we have a box of 13 sweets, we have 5 white chocolates, we have 2 black chocolates, 3 M&Ms, yellow M&Ms, and 2 red M&Ms. So there are 13 sweets in total. Let's just say I randomly select the sweets, okay? So the probability of getting a white chocolate is 5 out of 13. The probability of getting a black chocolate is 3 out of 13. The probability of getting a yellow M&M is 2 out of 13. The probability of getting a red M&M is 3 out of 13. Now, let's just say I know something already. Let's just say I know the thing I selected is an M&M. So, for example, the probability that I've given that it's a M&M, what's the probability that it's a yellow M&M? Okay, so given that I know it's a M&M, what's the probability of getting a yellow M&M? So I know that the probability of getting an M&M, so given that it's already an M&M, I'm going to do this in a different color. Given that it's already M&M, we know there are 5 M&Ms in the box. Okay, so all you have to do is you put 5 at the bottom, out of 5, of which are yellow, are 3. So it's 3 out of 5. Okay. More generally, to work out the conditional probability, if I have a probability of A, given I know B already, then the way I work this out in terms of a general formula, it's the probability of B. B becomes your new total. That's like your new sample space, because like with the M&M example, that's my new sample space. So out of 5, 3 is the ones I want out of 5. So at the top, I would want the intersection with B and A. Okay? So probably B and A given B. So write this formula down in your book, because that's the formula you'll be using a lot, okay? If I use this formula, I get the same answer. So if I want yellow, given that's an M&M, we know the probability of getting M&M in total is 5 out of 13 in the box. The probability of getting a yellow in the box is 3 out of 13. So when I simplify that, I get 3 out of 5. So it's the same answer as that. But I just like to go straight here because it's more intuitive as to, if we know that's an M&M, then we know that out of 5 M&Ms, we get 3 that are possibility that are yellow. So let's do example for question 1. A fair die is rolled, so the probabilities of rolling 1 to 6 are the same. A is defined as rolling a 6, and B is defined as rolling a number greater than 2. Okay, so let's use the formula. The probability of, so we know that we want probability of A given B. So given prior information, given event B, which is rolling number greater than 2, what's the probability of getting a 6 from that? Okay, so you can apply the formula directly, because we want probability of A intersection B divided by probability of B. So the probability of B is a number greater than 2. So it's 3, 4, 5, 6, 4 out of 6. And the probability of getting a 6 is 1 out of 6. So if I simplify that, it's just 1 out of 4. Another way to view this is you can draw it visually. So if I have the numbers 1, 2, 3, 4, 5, 6, given that we know that it's greater than 2, so greater than 2, that's my new sample space, what's the probability of getting a 6? So the intersection would be here. So out of the four samples, we know one of it is 6, so 1 out of 4. Okay, which is the same answer here. So the idea for conditional probability is that where given new information, it changes the overall sample space. Okay, it reduces the sample size. Okay, let's look at question 4. Sam's class of 12 students play violin, and 12 play piano, and 7 play both. Draw a Venn diagram and find the possibility that random chosen student plays violin given that they play piano. Okay, so I'm going to draw a Venn diagram of the two things they could play. Okay, so they could either play violin or piano. Okay, and we know 7 play both. So the students that play piano, a violin or piano, would be so it has to add up to 12. So this has to be 5. This has to be 5, because we know that total of violin is 12. The total of piano is 12. Okay, and 7 play both. So it has to be like that. Okay. We assume that 0 play neither. Okay, from the sample. So we're trying to find the probability of violin given that they play piano. Now, if you're wondering what the dash sign means, it means given. Okay, so it's a shorthand. Instead of writing given all the time, this is a shorthand for writing given. So we want the probability of P, because it's a probability of P according to the formula P V intersection P. Okay, the probability of getting P is, okay, it's 12 out of so there are a total of 5 plus 5 plus 7, which is 17. 5 out of 17, because there are 17 in total. And we want V intersection P. So V intersection P, so out of my new total, out of these students, how many play violin and piano? Well, the intersection is 7. So 7 would be what I want to calculate the probability of. So it's 7 out of 17. So overall it's 7 out of 12. Alternatively, you can just view the, view this side, because we're interested in, given that they play piano, what's the probability they play violin too? So piano, the total is 12. Total is 12, and out of that 12, 7 play violin as well. So you can apply the formula, or you can, if the question's simple enough, you can apply the logic. Okay, so for question 7, 100 people were questioned, classified according to sex and whether they think private individuals should be allowed to carry guns. The results are shown on the table. So, alright, so we have like a two-way table, or a Kano map. It says one person selected randomly from these 100. Given that the selected person is male, what is the probability that they think private individuals should carry guns? Okay, So what are we given? We're given that the person selected is a male, and we want to find the probability that they are allowed to carry guns. So first step is we're given prior information. We're given that they're male, so we can ignore the females. So given that they're male, so I'm looking at this column. We're not interested in females. We want to know out of those males, which one which one agrees that they should be carrying guns. So out of the column, this is the one we're interested in. So the probability of carry guns, given that it's a male, would be out of 60, because the column here is out of 60. That's our new total. It's not 100 anymore. Out of 60, the probability of wanting a gun is, for males, is 35. So you can simplify that. You should get 7 on 12. Okay. So again, it's our new total and whatever we want in that new total. Okay. Does that make sense? So the idea is you want to find out what your probability is given in light of new information. So we've already narrowed down our sample space to this instead of the whole thing. Okay. So we're not doing it out of 100 anymore. Again, if you want to apply the formula, you could go 60 out of 100 and 35 out of 100. You still get the same answer, 7 out of 12. Okay. So, in summary, the probability of A given B is the probability of A intersection B divided by the probability of B, because this is your new total, or the new total sample space. Okay. Now, sometimes questions don't say given. You've just got to recognize that you're given new information. I'll go through more examples where we apply the formula and rearrange it to get new information. This will be in a separate video.